Hello everyone, we are Group 10. Our group consists of 5 members Abdul, Ali, Ankita, Helen, and Jasmine. Here we are going to discuss about the site remediation strategies that we have proposed for an abandoned ore processing unit. As we all know, the environment is getting exploited due to the stress from increasing population and urbanization. The impacts are created by the consistent change in the lifestyle of people and pressure on the existing natural resources. The remnants of historical industrial activities cause impacts to the environment as well as the human life that can impede the further utilization of land. Here comes the importance of site remediation. It is the process of implementing strategies to clean up the environment by removing hazardous contamination disposed on the land. Remediation strategies can be divided into three. First one is monitor natural attenuation. The contaminated land will get remediated naturally with the help of indigenous microorganisms. Second one is containment. Here, the pollutants are immobilized and reduce the spread of contaminants. The third one is remediation. It includes the complete destruction of chemicals. Next, I'm going to introduce our study location. The site has been used for processing of ores and minerals. The unit has different zones of processing minerals, which includes roasting zone, crushing zone, and waste dumping zone. The site also consists of a laboratory building constructed of asbestos materials, particularly on the roof. The site has two above ground diesel storage tanks. Moreover, the northwest part of the site was used as agricultural land that was affected by bushfire. Hence, we have found that the location is terrifically contaminated with four major pollutants, namely heavy metals, fuel hydrocarbons, asbestos, and ash from bushfire.
I will start describe the site characterization and risk assessment. Can you move? Yeah. The first pollutant contaminated area is ore processing, dumping, crushing, and roasting zone, which has a heaps of contamination of heavy metals, including lead, arsenic, and mercury. These heavy metals have very severe health effects to human and aquatic life. And I also calculated the risk rating that is pretty high. The remedies suggested are microbial bioremediation, phytoremediation, soil replacement, and thermal desorption. The second contaminated areas are diesel storage tank, and there is a hydrochemical contamination is found in the soil, which can lead to the ecotoxicity of the environment, can cause greenhouse gas emissions, and diesel is less biodegradable and can remove nutrients from the soil. So remedies suggested for hydrochemical control is phytoremediation and bioventing methods. The next polluted area is agricultural land of the site, which was burnt in the recent New South Wales bushfires, and there's a heaps of ash contamination is present. Ash can lead to the soil and groundwater pollution and a serious health hazard to the human and aquatic life. The suggested control measures are basically bioremediation and sprinkler system, silicon extraction technology. And the last contaminated area is ore processing lab building and offices. The building was constructed with the friable and non-friable asbestos material, particularly in the roof sheeting and the walls of the building. And asbestos material is hazardous to the human health. On inhalation, it can cause lung cancer and also cause soil and water pollution during demolition. So the best solution is basically the removal of asbestos from the site.
Hi everyone, my name is Helen Samuel. I'm here to give a presentation on the topic site remediation strategies. It is the process to detect, assess, and finally eliminate the contamination from the site that has been polluted. It does not aim entire decontamination, but to bring the contamination level well below the regulatory toxic limit. There are a number of technologies to treat contaminations. Depending on the site conditions, pollutants, the site remediation technologies can be classified as chemical, physical, biological, and thermal. So these are some of the recommended site remediation strategies for asbestos, which includes treatment on site, removal off site, air quality management. And coming to the hydrocarbons, it is in situ steam injection vapor extraction, in situ soil vapor extraction, air spaging, and phytoremediation.
Hello, I'm talking about the heavy metals and fly ash remediation for a site. So there are 4 methods that can be used for site remediation for heavy metals. That is immobilization, soil washing, thermal desorption, and phytoremediation. Immobilization strategies are used to prevent heavy metals from leaching into the environment. Soil washing is used for physical separation or chemical extraction procedures, or a mix of two that are used to separate toxins in the soil from non-contaminated soil particles. Thermal desorption is a method based on pollutant volatility and involves heating contaminated soil with steam, microwave, or infrared radiation. Last is phytoremediation. The recent research has revealed that removing heavy metals and radionuclides from the soil is more difficult, but they can be efficiently neutralized or transformed into less harmful metabolites. Through their intrinsic catabolic mechanism, microbes are capable of biotransforming, biosorbing, and biomineralizing heavy metals and radionuclides. Next is fly ash. So fly ash is a byproduct of coal combustion in thermal power plants that can be used to generate electricity in a sustainable way. The two methods suggested are bioremediation and sprinkler system along with silicon extracted technology. As the name suggests, it is when landfill controls fly ash, dust, and moisture with misting dust suppression technologies. And silicon extraction technology is achieved by leaching fly ash with Enve solution containing more than 40% biomass, where silicon is leached from the fly ash in the form of sodium silicate. Fly ash is an ideal soil amendment for plant growth as an organic nitrogen and carbon replacement because it contains more micro and macronutrients as a high porosity.
So next we compare the technologies on the basis of cost. So we have selected two technologies for fly ash, hydrocarbons, and heavy metals. And we have only selected one technology for asbestos. That's the removal of asbestos by certified asbestos removalists. We have selected these technologies on the basis of literature. So when we talk about asbestos removal technologies, we have to remove 12.88 ton of asbestos from our site, which would incur a total cost of $201,096. 1% of this would go to the disposal cost, and 23% is the, can you please go back to the asbestos removal? Yeah. So 23% is the labor cost, and most of it goes towards the certified removalist charges. So then we talk about the hydrocarbon removal. We have, can you please go back? We have phytoremediation and bioventing. Phytoremediation is a little bit expensive, but it is still preferable because it can also remedy ash and heavy metals also. So one of this technique gives benefit to 3 of the pollutants, so it saves us cost. And then we talk about heavy metals. So heavy metal has microbial bioremediation and soil replacement and thermal desorption techniques. Microbial bioremediation is selected on the basis of the cost because it only incurs $29,000, and soil replacement and thermal desorption incurs $179,000. So lastly, we talk about ash. The technologies for ash also include bioremediation and sprinkler system silicon extraction technology, as it has been mentioned earlier. We would be selecting bioremediation because bioremediation would give us removal of hydrocarbons, heavy metals, and ash. And asbestos will only need one, which is the removal by certified professionals. Next slide. Yes, so these are the selected technologies, and that's all.
Moving on to the actual site remediation strategies for asbestos. The collected asbestos from the site is wrapped and contained in a well-equipped manner, such that the fibers are prevented from entering the site. The wrapped material is labeled with an asbestos hazardous symbol. The loading transportation is carried out in such a manner that the transporting vehicle should always travel in an authorized route. And the soil sampling is done from an environmental consultant agency to identify the risk and the associated impacts. And finally, an asbestos clearance inspection is done for the area and the surroundings for the completion of asbestos removal work prior to the normal reoccupation of the site. And actual site remediation strategy for hydrocarbons employ live plant to purify polluted soil, air, water. Initially, the hydrocarbon toxicity and tolerance screening of potential phytoremediators were analyzed, and then isolation and characterization of rhizobacteria that promote plant development and degrade hydrocarbons. And finally, evaluation of efficacy and effectiveness of microbial assisted phytoremediation is done. Thank you.
Considering the benefits and costs associated of the remediation strategies, phytoremediation is the most suitable strategy to remediate the land polluted by heavy metals and fly ash. Helianthus anus L is particularly plant used for the removal of heavy metals because of its phytoremediation efficiency. Results have shown that the industrial contaminated soil had a significant impeding effect on the plantlets of H. anus as noticed by the reduction in growth of parameters compared to the standard. It is proven to be effective for decontamination of highly affected industrial soil. These are few of our references. Thank you.